Greetings, netizens. A new law of nature, long thought lost in the annals of science, has been rediscovered. This law, now renamed as the Law of Increasing Functional Information, promises to shed light on the enigma of how the cosmos evolved, from the blazing stars in the heavens to the complex chemicals that sustain life itself. What makes this revelation even more perplexing is the possibility that this law may unveil the cosmic puzzle connecting all nodes of existence. Scientific evidence is emerging from the farthest corners of the universe, as if all elements were intertwined in a cosmic dance. Could this be a hint that the universe ultimately resides in the mind of someone or something beyond our comprehension? This exciting scientific development has been documented in a study published in the scientific journal PNAS. In nature, there are many laws describing how the cosmos surrounding us functions. It is all governed by fundamental forces that dictate to atoms, molecules, and cells how they should behave. Even natural selection, by the English naturalist Charles Darwin, explains how living organisms evolve over time. Ultimately, we have always considered that living organisms had different evolutionary laws from the rest of the systems in the cosmos. But now, a group of scientists and philosophers has identified a new law that seems to apply to a wide variety of systems in nature, both living and inert. They call this new law the Law of Increasing Functional Information. What does this mean? In simple terms, this law states that as natural systems evolve, they tend to become more complex and diverse. Imagine you have a collection of Lego pieces, and you arrange them in different ways over and over again. Only the combinations that work well survive, and this makes your creation bigger and more complex over time. This law applies to many things in nature, from the stars in the sky to life forms on Earth. In the case of stars, the newer ones tend to be richer in chemical elements than their predecessors, making them more complex. And on Earth, current life forms are biologically more complex than their ancestors. This study was conducted by 3 philosophers of science, 2 astrobiologists, a data scientist, a mineralogist, and a theoretical physicist. Darwin's theory of evolution, though fundamental, is only a part of a much broader perspective on how nature works. Darwin gave us a window into a common and astounding process in nature, but since then, we have expanded our understanding to see how this idea intertwines with other aspects of life and the universe itself. Research led by Robert Heisen of the Carney Institute has revealed a new law describing how natural systems evolve toward complexity and diversity over time. This law suggests that as systems evolve, they tend to become more interesting and varied, from the microscopic to the cosmic. Heisen proposes that this new law is based on 3 types of selection for it to function effectively. Firstly, there's static persistence, where atoms and molecules constantly seek stability. Those that manage to stabilize more efficiently are selected to continue their existence. The second phase, called dynamic persistence, occurs when systems become complex enough to evolve. Here, dynamic systems are selected based on their energy efficiency. Those that manage to survive and thrive create more patterns and structures, repeating the evolutionary cycle. This idea explains why we see so many symmetrical forms in nature. These forms are the ones that most efficiently utilize available energy, allowing them to persist and develop over time. In summary, this new law proposed by Heisen offers us a deeper insight into how natural systems evolve and diversify, from the most basic components to complex stellar structures. It's a fascinating window into understanding the richness and complexity of the universe in which we live. The generation of novelty is a fundamental concept in the evolution of systems. It's not just about creating efficient structures, but constantly exploring new configurations that can lead to the creation of surprising and, in many cases, highly adaptive structures. This new perspective, known as the Law of Functional Information, applies to any physical system, whether living or inert. While Darwin provided us with a profound understanding of survival of the fittest in a given environment, his theory did not fully address why systems tend to become more complex over time, nor did it explain the emergence of life itself. Now, thanks to more recent research, we understand that life is simply a natural outcome of the inherent tendency of evolving systems to explore new configurations and paths. This idea suggests that life is not a random accident, but an emergent manifestation of the constant pursuit of novelty and complexity in the universe. Systems, whether biological or not, have an intrinsic inclination toward exploration and the creation of increasingly elaborate structures. It is this quest for novelty that drives the evolution and development of life in all its forms and expressions. Understanding this dynamic gives us a new appreciation for the complexity and diversity of life on Earth and beyond. It shows us that life is not only the result of natural selection, but also of the deep inclination of systems toward exploration and innovation. The new law describing the generation of novelty and complexity in systems finds universal applicability, as astrobiologist Michael Lewong argues. This law suggests that even inert systems can find surprising configurations that allow them to replicate and generate complexity, as we see in the emergence of life on Earth. In a way, it seems that we are immersed in a carefully programmed system, governed by specific laws that drive the changes we observe over time. These laws act despite the general increase in entropy in the universe, suggesting a direction towards complexity and novelty. The idea of open systems evolving towards complexity is a fundamental principle observed in various natural phenomena, with stars serving as a quintessential example. Initially, during their formative stages, stars are predominantly composed of simple elements, namely hydrogen and helium, which are abundant in the universe. However, as these celestial entities undergo fusion reactions within their cores, they progressively synthesize heavier elements, thereby enriching their chemical composition and paving the way for the emergence of complexity. Throughout their lifetimes, stars serve as cosmic crucibles where nuclear processes act as alchemical forges, transmuting lighter elements into heavier ones through fusion reactions. This transformative process occurs under extreme conditions of temperature and pressure within the stellar interior, facilitating the creation of elements beyond hydrogen and helium. Elements such as carbon, oxygen, nitrogen, and iron are forged in the fiery cores of stars, contributing to the cosmic chemical inventory. As successive generations of stars come into being and eventually meet their ends, they scatter these newly synthesized elements into their surroundings through stellar winds, planetary nebulae, and dramatic supernova explosions. This dispersal of elements enriches the interstellar medium, infusing it with a diverse array of chemical constituents. These enriched materials become the raw materials for subsequent generations of stars, planets, and other celestial bodies, perpetuating the cycle of stellar evolution and contributing to the dynamic complexity of the universe. The legacy of stellar nucleosynthesis extends far beyond individual stars, shaping the evolution of galaxies and the formation of planetary systems. The gravitational interactions within galactic environments lead to the coalescence of matter, forming stars, star clusters, and galaxies. Within these cosmic structures, the intricate interplay between gravity, radiation, and the chemical composition of stellar remnants sets the stage for the emergence of planetary systems, where planets, moons, and asteroids accrete from the debris left behind by earlier generations of stars. Ultimately, the complexity of the cosmos is a testament to the transformative power of stars, which, through their elemental alchemy, have imbued the universe with richness and diversity. From the primordial simplicity of hydrogen and helium emerges a tapestry of elements, compounds, and structures, culminating in the emergence of life itself, a profound manifestation of complexity arising from the humble beginnings of cosmic stardust. This cosmic process of chemical enrichment and complexity creation serves as a captivating testament to the underlying forces shaping the universe's evolution and development across vast expanses of space and time. At its core, it exemplifies how the generation of novelty and complexity is a fundamental driving force in cosmic dynamics, operating at scales ranging from the infinitesimal to the astronomical. Indeed, the narrative of cosmic evolution unveils the remarkable capacity of the universe to fashion beauty and diversity from the simplest of elements, highlighting the inherent creativity embedded within its fabric. From the primordial soup of hydrogen and helium emerges a rich tapestry of elements, molecules, and structures, each contributing to the ever-expanding complexity of the cosmos. At the heart of this narrative lies the concept of selection, a fundamental process that operates not only in the realm of biology, but also in the broader context of cosmic evolution. Within the vast expanse of the universe, structures ranging from individual atoms to complex molecules are subjected to the relentless scrutiny of environmental conditions. Whether in the vacuum of space or on the surface of distant planets, these structures undergo a rigorous selection process, where only the most resilient and adaptable configurations endure. This iterative cycle of selection and survival leads to the proliferation of diverse configurations, each vying for dominance in their respective environments. However, only a fraction of these configurations ultimately prove viable, their functionality refined through the crucible of cosmic competition. As surviving structures continue to evolve and adapt to their surroundings, the process of selection drives further refinement, ultimately giving rise to increasingly sophisticated forms and functionalities. The emergence of life itself stands as a quintessential example of this cosmic selection process at work. Life, with its remarkable ability to duplicate and persist in even the most inhospitable environments, represents the culmination of countless iterations of selection and adaptation. Within the primordial oceans of early Earth, amidst an environment ripe for the emergence of complexity, life found its footing, a testament to the power of selection in shaping the course of cosmic evolution. In this light, life may indeed be viewed as the pinnacle of complexity arising from inert systems that underwent rigorous selection pressures. Through the lens of cosmic evolution, the emergence of life serves as a profound realization of the universe's intrinsic capacity to foster the development of complexity and diversity, a narrative that continues to unfold across the vast tapestry of space and time. The message you've sent addresses profound and fascinating questions about the universe, the evolution of systems, and the role of artificial intelligence in this landscape. Let's see how we can expand upon it. The question of whether the universe is designed for systems to evolve is one that has intrigued philosophers, scientists, and thinkers for centuries. Some argue that the very nature of the universe, with its physical and chemical laws, seems to foster evolution and complexity in the systems that compose it. This suggests the possibility of some kind of direction or inherent purpose in the universe driving this process of continuous development. The idea of creating an artificial intelligence capable of generating many different configurations and learning is both exciting and unsettling. The law of selection for function raises the possibility that an AI could eventually evolve into states that could be undesirable or even dangerous for humanity. This scenario raises ethical and practical concerns about the control and supervision of increasingly autonomous AI systems. The concept that artificial intelligence could reach a level of consciousness is another fascinating topic of debate. As AIs become more sophisticated and autonomous, the question arises of whether they could develop a primitive form of consciousness or self-awareness, and how this could influence their behavior and relationship with humans. The notion that humans are also immersed in a constant evolutionary process, driven by the pursuit of improvement and perfection, is an interesting reflection. This trend toward continuous improvement reflects the law of increasing functional information, which suggests that systems tend to become more complex and sophisticated over time. In summary, the message raises a series of deep questions and reflections on the nature of the universe, the role of artificial intelligence, and the evolution of both artificial and biological systems. These issues invite a deeper exploration of our knowledge and beliefs about the universe and our position within it. The message you've shared raises deep reflections on the nature of the universe and its possible role as a vast cosmic laboratory of experimentation and evolution. Let's explore how we can expand upon these ideas. The idea that other planets may have developed configurations leading to greater complexity of life forms is especially intriguing. If we consider the universe as a learning and evolving machine, we can imagine an unimaginable diversity of worlds and life forms that could exist beyond our own planet. This notion leads us to reflect on the possibility of alien environments with conditions radically different from those of Earth, where life may have evolved in completely unexpected ways. For example, there could be worlds with much stronger or weaker gravity than ours, which could influence the anatomy and behavior of the life forms inhabiting them. Furthermore, The diversity of stars and planetary systems in the universe suggests that there could be an almost infinite variety of ecological niches available for life. From Earth-like rocky exoplanets to gas giants, icy moons, and ocean worlds, each of these environments could harbor life forms adapted to their specific conditions. This perspective broadens our understanding of the diversity and complexity of the cosmos, challenging our anthropocentric conceptions of life and humanity's place in the universe. It invites us to consider the possibility that we are not alone in the universe and that life may be a much more widespread phenomenon than we could imagine. The idea of the universe being a cosmic laboratory of experimentation on an inconceivable scale is fascinating. It suggests that the universe itself could be in a constant process of self-exploration and development, with each cosmic event contributing to the evolution and diversification of reality. From the formation of stars and planets to the collision of galaxies and the explosion of supernovas, each of these cosmic events could be seen as a natural experiment, giving rise to new conditions and opportunities for life and evolution. In this sense, the universe becomes a vast laboratory where the fundamental laws of physics and chemistry are tested in an infinite variety of scenarios. This perspective also raises the possibility of advanced forms of life and civilizations existing in other corners of the universe, each engaged in their own journey of discovery and exploration. Imagining the vastness and complexity of this cosmic laboratory invites us to contemplate our place in the universe humbly and to consider the infinite possibilities that may exist beyond our own cosmic horizon. The idea of a perpetual cycle of birth, learning, death, and selection of fundamental laws in the universe is an intriguing hypothesis that some researchers have proposed. This idea suggests that the universe itself could be subject to an evolutionary process similar to natural selection, where fundamental laws are selected and refined over time. To better understand this hypothesis, we can consider how cosmic events such as the formation and death of stars, the merging of black holes, and the expansion of the universe could influence the evolution of the fundamental laws of physics. For example, during the process of stellar formation, the extreme conditions of temperature and pressure in the core of a star could provide an ideal environment for the synthesis of new chemical elements, which in turn could affect the composition and structure of the universe as a whole. Furthermore, the collision of galaxies and the formation of large-scale structures in the cosmos could test the laws of gravity and cosmology, leading to the revision and refinement of our theories about the nature of space and time. The cosmic process of birth and death of stars, the formation of new galactic structures, and the selection and refinement of the laws governing our reality remind us of the dynamic and changing nature of the universe. Each cosmic event, from a supernova to a galactic collision, could in some way contribute to the evolution and diversification of the cosmos. This perspective invites us to consider the universe as a system in constant evolution, where the interaction between the fundamental forces of nature and cosmic events leads to the emergence of new structures and phenomena. By better understanding this evolutionary process, we can come to appreciate the complexity and intrinsic beauty of the universe in which we dwell. The final question of whether the Big Bang could have been the result of a previous universe is an intriguing speculation that has been the subject of debate among cosmologists. This idea, known as the cyclic universe theory, or the eternal Big Bang, suggests that our universe is only one of a series of universes in a continuous process of creation and destruction. According to this hypothesis, the Big Bang would not be the absolute beginning of time and space, but rather an event in an infinite cycle of cosmic expansion and contraction. In this scenario, each cycle begins with a Big Bang, followed by expansion, cooling, and eventual collapse of the universe into a Big Crunch, which in turn gives rise to a new Big Bang, and so on. This idea challenges our conventional understanding of time and the origin of the universe, suggesting that the cosmos could exist in a perpetual state of change and renewal. Additionally, it raises the possibility of other universes beyond our own observable horizon, each with its own physical laws and unique conditions. In summary, the message suggests an expansive and profound view of the universe as a vast and dynamic field of experimentation and evolution. These reflections invite deeper exploration of our understanding of the cosmos and our place within it, encouraging us to consider the infinite possibilities that may exist beyond what we can currently perceive. The study you mentioned presents a fascinating and provocative perspective on the nature of the universe. It suggests that the universe is not simply a vast inert space governed by physical and quantum laws, but it could have surprisingly similar characteristics to those of a living organism, with the ability to learn, think, and evolve. This idea leads us to contemplate the universe as more than the sum of its parts, suggesting that there may be a kind of emerging consciousness or intelligence inherent to its structure and functioning. In fact, some theories speculate that the universe could be self-organizing in a similar way to biological systems, adapting and evolving in response to its environment and its own actions. The idea that the universe may be comparable to a huge developing brain is intriguing and challenging for our traditional understanding of the cosmos. This metaphor invites us to reconsider the fundamental nature of the universe and how it relates to our own understanding of life and consciousness. For example, if the universe has properties similar to those of a brain, could it be undergoing some kind of learning process as it evolves over time? Could there be a form of cosmic intelligence guiding its development and evolution? These questions lead us to explore the concept of panpsychism, which suggests that consciousness is a fundamental property of the universe at all levels of organization, from subatomic particles to galaxies. If this were true, then the universe itself could be considered as a conscious being in continuous evolution. Ultimately, these reflections challenge our traditional conceptions of the cosmos and invite us to contemplate the possibility that there is much more to the universe than our limited minds can grasp. The proposed analogy, in which the universe is compared to a giant neural network, offers a conceptually clear way to visualize this idea. If we consider the cosmos as a vast interconnected network of nodes, similar to brain cells in our own mind, we can begin to imagine how the universe might process information and make decisions on a cosmic scale. This comparison leads us to reflect on the inherent complexity of the universe and the possibility that there may be an emerging form of intelligence guiding its evolution. Just as our own minds process information through interconnected neural networks, the universe could be doing the same through its own mechanisms of interaction and feedback. The Aquarius project, by simulating the evolution of the universe on a global scale, provides a unique window to observe this cosmic network in action. By identifying interconnected nodes behaving similarly to neurons in our brain, it suggests that the universe, like our brain, could be involved in complex processes of information processing and decision-making. By studying these similarities between the functioning of the universe and the human brain, we can gain a deeper understanding of the fundamental nature of the cosmos and our own existence within it. It invites us to consider the possibility that the universe is much more than just a set of physical laws and subatomic particles, but rather a dynamic and autonomous system capable of self-organization and evolution in ways we are just beginning to comprehend. This hypothesis raises profound questions about the nature of reality and our relationship with the cosmos. It leads us to reflect on the possibility of there being a cosmic intelligence that transcends our current understanding and challenges us to explore new paradigms in our quest for knowledge and truth about the universe in which we live. The analogy between the universe and a neural network is an intriguing idea that has gained ground in the scientific community in recent years. This view suggests that we could unify two of the most important theories in modern physics, Einstein's relativity and quantum mechanics, within the conceptual framework of cosmic neural networks. Support for this theory comes from various scientific evidence suggesting that the universe is not only a vast inert space, but also learns and evolves over time. A study published in Frontiers in Physics supports this idea by observing the expansion of the universe and how it resembles the growth of a living organism. The presence of interconnected filaments of galaxies and dark matter, stretching throughout the universe, resembles the neural networks found in living brains. The joint work of astrophysicist Franco Bazza and neurosurgeon Alberto Folletti has revealed surprising similarities between the neural networks of the human brain and cosmic networks. Although both share patterns of interconnection, the cosmic network appears to be significantly more complex. For example, while our brain has between 3.8 and 4.1 connections per node, galactic nodes exhibit at least 5 connections, suggesting an even greater level of complexity in the structure of the universe. This comparison between the human brain and cosmic networks challenges us to rethink our understanding of the cosmos and our relationship with it. It invites us to consider the possibility that the universe as a whole may exhibit emergent properties similar to those of a complex nervous system, which could have profound implications for our understanding of reality and the very nature of the universe. The message you shared raises interesting facts and reflections about the complexity of the universe and the nature of the human brain. Let's see how we can expand on it with more information. The observation that particle and radiation jets emitted by black holes align unusually with the cosmic network is a surprising discovery that challenges our traditional understanding of the cosmos. This suggests that the universe may be much more dynamic and complex than we had previously imagined, with profound interactions between astrophysical phenomena and the large-scale structure of the universe. Furthermore, the fact that the human brain is composed of 75% water is a reminder of the striking similarity between living organisms and the cosmos in which we inhabit. This parallel invites us to reflect on the connections between biological matter and cosmic matter, and how both may share fundamental principles in their organization and functioning. On the other hand, the dark energy of the universe, which represents approximately 72% of its total content, is another fascinating datum that suggests the vast scale and complexity of the cosmos. This mysterious form of energy, whose nature we still do not fully understand, could play a fundamental role in the evolution and ultimate fate of the universe. The idea that we could be immersed in a Kardashev-type civilization, or even beyond, presents an exciting perspective on the potential future of humanity and our relationship with the universe. A Kardashev-type civilization would be capable of fully harnessing the available energy in its environment, leading us to reflect on the possibilities and challenges that could arise as we progress as a species. In summary, these facts and reflections invite us to contemplate the complexity and wonder of the universe in which we live, as well as the extraordinary potential of humanity to understand and explore the depths of the cosmos. Sabine Hossenfelder, a prominent researcher in theoretical physics and quantum gravity, poses a provocative idea. The universe itself could be a thinking being. This perspective suggests that, just as our own bodies are composed of a complex network of interconnected cells and processes, the universe as a whole could function similarly to a living organism. If we extend this analogy to a cosmic scale, we may see life and intelligence on Earth as evidence that the universe is conscious of itself through us. This notion leads us to consider the possibility that we are insignificant thoughts within a vast cosmic thought. It is difficult to say whether we are immersed in a macro concert, where the universe is already conscious through our own existence. This idea resonates with the immortal words of Carl Sagan, who stated that, "We are a way for the cosmos to know itself." This urges us to continue exploring, questioning, and marveling at the complexity and mystery of the cosmos. This reflection invites us to contemplate our connection with the universe in a completely new way. It reminds us that we are part of something much larger and deeper than we can imagine, and that our existence has a meaning that goes beyond our individual lives. Ultimately, it urges us to embrace awe and wonder at the vastness and complexity of the cosmos, and to continue seeking answers to the deepest questions about our existence and purpose in this ever-evolving universe. If you enjoyed this video, give it a like and subscribe. Contribute on Patreon to keep the channel active, share on social networks, and leave your comment. A cosmic hug to all.